Okay, sixth graders, we're going to work on a lesson on exponents. Exponents are the little numbers that tell you how many times to multiply the base number by itself. And I want you to write down that definition. Okay?
Take him. You're the only one left?
No, actually take me. You can do take me.
Okay, you'll have to go.
Take me.
So,
When are my parents?
Take him.
the little numbers that tell you how many times to multiply the base number times itself. Okay? So, here's an example of a power of a number. The word power refers to a number and its exponent. Okay? That's written as a power. A number, the base number, and the exponent is called a power of a number. And so we can read this as 5 to the third power. 5 to the third power. The 5 is the big number, that's the base number. 3 is the exponent, and that tells us how many times we should multiply the base times itself. Okay? So what this means, 5 to the third power, 5 to the third power means 5 times 5 times 5. 5 times 5 times 5. Multiplying the base times itself 3 times. Matt?
That's actually not 125, so.
Yep, 125. 5 times 5 is
5 times
25.
5 is 25. Then what's 25
And
times
25 times 5 is 125.
Oh, I thought it was just 5 times 5 times 5 just by itself, no 25 added.
But 5 times, we would find the answer by doing 5 times 5, which is 25.
And then you times it.
And then times it by another 5. And if you count by 25s, 25, 50, 75, 100, 125. That's how we get 125. Okay. 25 times 5. Now, another way to say the third power, there's a special name for the third power, and that's called cubed. Anytime you have a third power or something to the third power, you read this as 5 cubed. Okay? So anytime you see the word cubed, it means a number to the third power. Anytime you see the word squared, that means a number to the second power. So 5 squared means 5 times 5. Or 5 squared equals 25. Okay? Now, a common mistake that you have to watch out for with powers is that you don't find the answer by multiplying the base times the exponent. If you did that, you'd get the wrong answer. 5 times 3 is 15. This does not mean 5 times 3. This means 5 times 5 times 5. 5 times 5 times 5, 3 times. This means 5 times 5, not 5 times 2. Okay? So you got to watch out for that mistake. Let's talk about a special case. And that's a number to the 0 power. So write down some examples. First of all, the rule is that any number to the 0 power is equal to 1. The answer is always 1. Whenever you see a number, even if it's a variable, a letter, the answer is still 1. Any number to the 0 power equals 1. Okay? Now, a common mistake again is to write 0 as the answer. 5 to the 0 power, oh, that must be 0, because 5 times 0 is 0. And that's true, 5 times 0 is 0, but then we don't find the answer by doing the base times the exponent. We do we find the answer by multiplying the base times itself, but in this case, there's no other number. So you just have to memorize this, that 5 to the 0 power, or 7 to the 0 power, or 3 to the 0 power, any number to the 0 power is always 1. Okay? Now, let's look at, again, this is a common mistake. 4 squared. 4 squared does not equal 8. Okay? It equals 16. Because 4 times 4 equals 16. Okay. Any questions on that? So, you can write numbers, you can find the answer when you're given a power, and you should be able to find an answer. Let's see here, I got the notes on that. You should be able to find an answer when you are given an expression like this. 3 times 3 times 3 times 3 times 3. How would you write this as a power? How would you write this expression as a power? So not the answer in standard form, but let's just take this expression and write it as a power with a base and an exponent. Armand?
3 to the 6th.
3 to the 1, 2, right, 3 to the 5th power. That's 3 to the 5th power, okay? How would we write, let's see, how would we write this number using powers? The question is, how would we write these digits as an expression? Okay? So, everybody watch. How much is this 4 worth? How much is the 4 worth, Josh? Just 4. How much is the 9 worth? 90. And how much is the 6 worth? 600. Yep. Let's work starting with the 600. And we're going to take this 600 and we're going to break it up into 6 times 10. But instead of 6 times 100. But then I want you to think of a way to write 100 using a power. How could you write 100 as a power? Tyler?
Wait. Oh, I know.
We're going to start with 10 and do what power? 10 to the what power would equal 100?
4?
Close.
5.
Lower.
3.
Lower.
2.
Yeah, 10 times 10, right?
Oh, yeah.
10 times 10 equals 100. Since 10 times 10 equals 100, we could write this as 10 to the 2nd power, 10 squared. Okay? In fact, all of our digits, or all of our place values, can be written as powers of 10. Let's start with the ones place. Remember the rule that we learned about writing the 1? What is always equal to 1? Read in.
1 to the 1st power?
Any number to the what?
0.
To the 0 power. So that means 10 to the 0 power is equal to 1, isn't it? And that's the first place in our chart, the place value. Let me write it this way for you. You often see this chart written up and down, but what if we could write it going across? So look at this pattern, everybody. Let's get rid of this. And let's write the ones place as 10 to the 0 power. Because 10 to the 0 power equals 1. Okay? How would we write the tens place? How could we write the number 10 as a power? Does anyone know? Just the number 10, right? It's actually just 10 to the first power, means 110. And the hundreds place, we already said is 10 to the what?
Second power.
Second power.
The square.
10 squared. And the thousands place is 10 to the what? What's the pattern? Look at the pattern, everybody.
Third.
Olivia. Third power. Right? Could we keep going?
Yeah.
Yeah. Now, look at another pattern. How many zeros does the number 1 have? 0 zeros. The exponent is 0. How many zeros does the number 10 have?
1.
1 0. And there's 1 0 in the number 10. How many zeros does 100 have? 2 zeros. And the exponent is 2. How many zeros does 1,000 have? 3 zeros. What's the exponent for thousands?
3.
3.
So it's a pattern.
So the exponent tells you
How many zeros?
how many zeros are in the number, doesn't it? 1,000, 100, 10, 1. The exponent indicates how many zeros. Now, we said that you could write 600 as 6 times 100, right? So then the next step would be to write it as a power of, to write 100 as a power of 10. And then put it together. So 6 times 10 to the second power. Okay? Now, remember when we wrote these numbers in expanded form? So 600 plus 90 plus 4. Does everybody remember when we did that? It was like one of the first assignments that we did. Was writing this number as in an expanded form to tell you the value of each digit. Remember that? Now, instead of writing 600, we wrote it as 6 times 10 to the second power. Can we write 90 as a power of 10? So instead of 6, you write 9 times 10 to the what power? Instead of the second power, it's the what? Look at the pattern. We're going down the chart. 6 times 10 to the second power. 9 times 10 to the
Power of 1.
power of 1, first power. And then the 4 is just 4 times 10 to the Next one down. Bennett? Power of 0. Very good. So each of these expressions are ways of writing the value of these digits. 6 times 10 to the second power is another way to write 600. Okay, everybody listen to this now. Focus, Matt. Look up here. Eyes up here. Everyone, Peter. 6 times 10 to the second power is another way of writing 600. Right? And 9 times 10 to the first power is equal to 90. And 4 times 10 to the 0 power is equal to 4. So taking this expanded form that you already know how to do, and you can write this as an expression using powers of 10. Okay? So we're going to practice that for tomorrow. From page 21, I want you to do 7 through 14. 7 through 14. Okay?